Hello everyone, this is the first experiment on the fundamental physics laboratory. So due to the pandemic situations, we are going to have online experiments. Then the data will come up at the end of the videos or at the end of the sessions, and then you're ready for the calculation and analysis. You provide the report and submit it to the assistants. Then we will evaluate what you can do your best. Okay, this is the density of matters, the first experiment on the fundamental physics. So what the aims of this experiment is to determine kind of the solid materials or objects and liquid objects. Materials and tools that we are going to use for this experiment. I'll try to explain one by one. From the top left corner here we have the scale or the balance. This is the torsional balance. So this is pretty much very familiar for all the students. So the purpose you use this scale is because you need to know what is the mass. Back to the rho formula, you need to know the volume of your objects and the mass. Okay, then left we move right. This is the pygnometers. So this is kind of the containers, very fine containers made of glass with a very specific and very thorough volume on it. So this is made of a special glass, so the volume is going to be not quite varying when the temperature is varied. So the next one is vernier caliper. This is the length measurement. So you can find very thorough measurements through the vernier caliper. You can put your objects on the jaws between the static and the dynamic jaws on the bottom, and then you will see the zero scale on the vernier caliper corresponding to your main scales, and so on and so on. From the first, the second and the third scale, pygnometers and vernier caliper are going to use for the determinations of the density for a solid, which is wooden block as well as sand. For the bottom left corner here, Mohr-Westphal balance. What we had here is the left picture, and the right one is just coming from the internet. So Mohr-Westphal balance are pretty much like the balance that you have the mass on the right hand side, and then the needle, which is it's going to be very balanced between the left and right. So the torsional between left and right is zero, so then it's quite balanced. Once you have the object on the right, then the torsional is going to be positive on the right, and that's going to be imbalance conditions. So by using the Mohr-Westphal balance, we are going to be able to determine the density of the object here. The density of the material, which is liquid, is able to be determined using Mohr-Westphal balance. So in this case, you're going to use methanol. First of all, you're going to determine the density of the wooden block in the very precise cube shape. So you need to measure the width, the length, and the height of the object. So you can use the vernier caliper in this regard. This is the examples how you measure the weight of your object. So for example, the wooden object you put in between of the bottom jaws on your vernier caliper, and then you read through the non-linear scales, which is vernier scales regarding relatively to the main scales on your sliding through. So this is the first step. You need to determine and take the data of your object, which is the wooden cube. So in this step, we're gonna measure or weighing the object on your balance. So first of all, you just put your object on the scale or on the balance. It's gonna be imbalanced, so you need to put back the balance of your scale. So on the balance or on the scale, you will see that there's couples of sensitivity. The first one is gonna be the very large mass. You can move to left and right, and the second one you're gonna have the medium one, or maybe the smaller one. Then the very fine one is just the little mass which you can slide through left and right. So then once you have done by the formula of the volume, you calculate from the multiplication of length, width and height. So by knowing the mass and the volume, so you will already know the density of your objects. Okay. The next one, to determine the density of sand. First of all, we need to determine the weight of the picnometer as a container. So put it in the scales, weigh it up properly, then you will get the mass empty picnometer. Now fill it up with sand, about 1/3 in volume, and then you weigh it on the scale. Now then, what you need to do is fill up with the water as much as it's gonna be very full. So you will have the mixture between water and sand. Then you need to shake it gently and properly, so to make sure that the water can fill up the rooms between the sand's particles. Okay, then put the lid back on to the picnometer, and then you're ready to measure the weight of this system: the sand, the water and the picnometer. You need to empty the picnometer and fill it up fully with water. So make sure there is no sand, make sure that it's empty. Then fill it up with just water, fully water. And then you need to measure to know what's the mass of picnometer and the water in it. Okay. So then you're ready for the calculations. Now we come up with the last experiment, which is to determine the density of liquid. In this experiment we are using methanol. Okay, so this is what actually happening when you are using the Mohr-Westphal balance. First of all, you need to make sure that the needles in the left end here pointing to 0, which is all the systems are in balance. As you already have the liquid in some containers, for example, and then you put your object, which is more object, into the liquid. So put it immersing into the liquid, and then you will see that the buoyance will be produced to lift the balance up. You need to apply the masses along the axis. So there are notches, so you can modify in which configuration the masses need to be applied. Once the balance is back to the system, so you just multiply the torque all of the masses. So for example, the first mass times the first arms plus the second mass times another arms, the second arms, and so on and so on. So you will be able to determine the buoyant force, okay? Because all of the total force here indicated the buoyant force produced by your liquid. So by doing the formula of the Archimedes force and this moment torsions or moments, so you're able to determine the density of your liquid. All right. So enjoy the video and we will be happy for some questions. So good luck with your calculations, with your analysis. Thank you.